Hello and welcome to the Statistics for Data Science lecture series. This is a beginner friendly course, so if you have not done any statistics before, do not be worried because we'll cover everything from scratch. Okay, so let's start the video. In this video, we are going to look at all the tools which are available to us for exploring a given data distribution. So let's look at the key terms for exploring data distribution. Box plot. So this is a plot which is used to visualize the distribution of data. We'll look more into it in the coming slides. Next we have a frequency table. So frequency table is a tally of the count of numeric data values that fall into a set of bins or categories. Next we have is histogram. So histogram is a plot of the frequency table with the bins on the x-axis and count on the y-axis. And finally we have density plot. A density plot is a representation of the distribution of a numeric variable that uses a kernel density estimate to show the probability density function of the variable. So let us look at each one of them one by one. Box plot. Box plot shows the 5-number summary of a set of data. So we have minimum score, first quartile, median value, third quartile, and maximum score. So let us look at each of these terms. So minimum score is the lowest score excluding the outliers. So if we look at this diagram, so this is the minimum score, okay, and these are outliers. So while assigning the minimum score, we do not consider the outliers, okay. Next we have the first quartile. So 25% of the data fall below the first quartile value. So this is the first quartile, and this data is constituting 25% of the total data set. Okay, so this is the first quartile value. Next we have median. The median marks the midpoint of the data and is shown by the line that divides the box into two parts. Half of the scores are greater or equal to this value and half are less. So this value right here gives us the median value. Okay, and so this data is 50% of the data, total data, and this is the rest 50%. Okay, so median is like the value which is dividing the data set into two parts. Next we have third quartile. So 75% of the data fall below the third quartile value. So this is our third quartile value. So this right here, you can call it Q3. So this from here to this part is constituting 75% of the total data set. Next we have the maximum score. So the highest score excluding the outliers shown at the end of the right whisker. So this is the maximum score. And next we have whiskers. So the lower 25% of data and the upper 25% of data are called as whiskers. So this part lower whisker, this part is lower whisker, and this part is the upper whisker, right? And finally we have interquartile range. In short it's called IQR, and the box plot showing the middle 50% of the data. So you can also call IQR is also equal to Q3 minus Q1. Okay, so this region is the interquartile range, right? Okay, next we have the frequency table. A frequency table is simply a table which outlines the various possible outcomes and the associated frequencies observed in a sample. So suppose we have these are the categories. So someone getting scores from 10 to 20. So we have two, like there are two probably. Let's talk about a student scoring marks. So students scoring marks. So basically there are two students who have scored marks in between this in this range, okay, 10 to 20. Next we have from 20 to 30 we have 3 students, so we have a frequency of 3. From 30 to 40 we have 2, so we have 2 students. 40 to 51, so 1 is the frequency. And 50 to 60 again we have just 1 student, and frequency is 1, like that. Okay, next we have our histograms. A histogram is a display of statistical information that uses rectangles to show the frequency of data items in successive numerical intervals of equal size. So a histogram is a way to visualize a frequency table with bins on the x-axis and a data count on the y-axis. In general, histograms are plotted such that empty bins are included in the graph. Bins are like of equal width. For example, in these, if you see, these are of equal width. The width are same for all these bars. Number of bins is up to the user, and bars are contiguous. That is, no empty space shows between bars unless there is an empty bin. Okay. So next we have our density plots. A density plot is a smooth, continuous version of a histogram estimated from the data. A key distinction from histogram is a density plot corresponds to plotting the histogram as a proportion rather than counts. In statistical theory, location and variability are referred to as the first and second moments of a distribution. The third and fourth moments are called skewness and kurtosis. Skewness is a measure of asymmetry of a distribution. Kurtosis is a statistical measure used to describe the degree to which scores cluster in the tails or the peak of a frequency distribution. The peak is the tallest part of the distribution and the tails are the ends of the distribution. So this is an example of a symmetrical distribution. So both these halves are equally divided. So this is representing 50% of the data, and this is also representing 50% of the data. And in this case, mean is equal to median equals to mode, right? These are examples of asymmetric distribution, where this is positively skewed distribution and this represents a negatively skewed distribution. Here, see, this is the most occurring data, right? So this gives us the mode. Similarly, for this graph, this gives us the mode. In this positively skewed distribution, mode is less than median value, and mean is the greatest value. Okay. While in negatively skewed distribution, the mode value is the largest, followed by median and then mean. Next we have kurtosis. This is a normal distribution, the red one. Then the next one is leptokurtic distribution, where the peak is higher than the normal distribution, and the other one where the peak is lower than the normal distribution is platykurtic distribution. Let us now open a Jupyter notebook and see how to implement this in Python. Okay, so I have opened my Jupyter notebook. So at first we'll import the required libraries. I'll just write a comment. The required libraries. Okay, so I'll import pandas as pd. I'll import matplotlib .pyplot as pnt and import seaborn as SNS. Okay. So at first I'll use this link, and then like this link has a CSV file. So next what I'll do is I'll do a read.csv and pass on the URL as my argument, then print out. Look at what the data frame looks like. So this is our data frame. Now what I want to do is we have a question, so we'll have to create a box plot for beauty scores differentiated by credits. Okay, I'll just write down the question. Okay, so for this we'll use the seaborn module. So we'll do sns.boxplot and then pass on the data, which is our data frame. X will be equal to the beauty column or the beauty so the X column will be beauty, and Y will be basically the one we'll use to segregate the different beauty values is credits, right? So once we do that, we can see that this is our box plot. And yeah, so based on credits, whether it is single or more, we have segregated, and these are our plots, right? These values are outliers. These are the whiskers, lower and upper whiskers. Okay, median values, and first quartiles, third quartile, interquartile range, all that we discussed. Okay. Next, what I want to do is I want to create a frequency table. So create a frequency table counting the number of male and female. Okay, so for this we'll use the pandas library and use the cross step function, where in the index we'll pass on the values of the gender column. Next, we'll use the count function to count the values, and we'll also give column names, and let's call it serial number. Okay, see, and we can also use the reset index, because then it'll look fine. So we have serial numbers. Okay, so we can see that the number of female professors are 195 and the number of male professors are 268. So this is an example of a frequency table. Okay, so we can use the cross step function from the pandas module to achieve this, right? So next, what we want to do is we want to plot a histogram showing the teaching evaluation scores. Okay, so for this we'll again use the Seaborn library, and then use this histplot function, then pass on our data, and our x will be evaluation score, right? So from this you can see that this is what is plotted, and if you look at this data, we can say that this is a negatively skewed distribution, right? Next, if we want to plot a density plot, so what again we'll use the Seaborn library, and we can use KD plot, pass on the data which is equal to our data frame, and x is basically the evaluation score, and you can see it's basically the rough estimate of this histogram. Okay, so this is not a normal distribution, or it is skewed, and it is negatively skewed, right? So this is how you can sort of plot the different graphs with data provided. So this is it for this video. In the next video we'll be looking at how to deal with binary and categorical data. So if you found this video helpful, please give it a like, share it with your friends, and subscribe to my channel and hit that bell icon to never miss an upload. Thank you so much for sticking by, and I'll see you guys very soon.